single replacement reaction, you get this kind of magical new product that seems to have appeared from nothing. So in this example, you can see that when you put an iron nail into a solution that's a copper sulfate solution, that's CuSO4, this leads to the formation of copper. So you'd actually see this iron nail that's sort of a silver color turn to this copperish color because of the formation of copper. So it looks like magic, but because it's chemistry, we know it's not magic. It's a single replacement. It's a chemical reaction. So this is an example when you see something appear that's a new solid that wasn't there before. It's called a metallic deposit. And so let's look at this example of copper and silver nitrate that we just wrote out that equation of silver nitrate. It starts off clear silver nitrate solution and brownish copper. And over time, this copper starts to have this blackish look to it. And so what's happening is the formation of silver. This wasn't there before. And you can also see a kind of bluish tinge to the solution in the beaker because what's happening is that silver solid is forming. So now it's turning kind of grayish, and meanwhile that copper is disappearing. Also, the bluish color is the formation of the copper nitrate solution that has a bluish color. So when you see change, you're looking at a chemical reaction. When you shake this whole thing, you can shake off the silver solid that forms, and it'll all end up at the bottom of this beaker. The metallic deposit is not the only possibility for a single replacement reaction product. There's also the possibility when the new element that's formed isn't a metal but can be a gas, and you will recognize that because you'll see bubbles that are formed. So we'll see this example as well in lab, but when you take a piece of zinc, a solid piece of zinc, which is silver, and put it into hydrochloric acid, which is a clear solution, the single replacement reaction only occurs if the metal alone is more reactive than the metal that's in the ionic compound. If the metal alone is less reactive, okay, and that means it's lower on the metal activity series. If it's less reactive than the metal that's in the compound, then there's not going to be any replacement reaction. And so what happens when there's no replacement reaction is you don't see any change, and that's called no reaction. Okay, so no reaction because no change because there was no replacement. So this is in the general format A plus BC if A is the lower metal or less reactive, then you don't have any reaction that occurs. Okay, and that no reaction occurs because A is less reactive and it does not replace B. And form a new ionic compound. So the example of copper and zinc nitrate is if you have copper and the compound ZnNO3, this copper is less reactive, and this will not replace the zinc. And so this is an example of no reaction, and you don't write anything on the other side of the reaction arrow. There's no different. You could actually just rewrite the copper and the zinc nitrate. So how this looks reaction is predicted to happen, and this is because you have a higher metal, and this is the metal alone on the reactant side, that this will set up a replacement.
So first, that metal has to form an ion, and you want to write that ion which is going to be a positive charge cation with the charge value using the activity series. And then you use the crossover rule to write the cation, that new ion, with the anion from the original ionic compound, that was in the reactants. And then you have a new ionic compound, and this is new on the product side. So now you've got the higher, more reactive metal replaces the lower, less reactive metal. Figure out the ion using the activity series. Write the new ionic compound. Use the crossover rule to write the chemical formula where the charge values become subscripts. And then you have a new ionic compound and you have a new element. So this is this process where A plus BC and the new ionic compound, showing you in a different color, are going to be this AC, and the new element was previously that this ion, and is now no longer an ion. So now this is an example of this metallic deposit that we looked at before, where you have, this is copper and silver nitrate. And so what happened is that copper formed the copper ion, or copper is more reactive. Let's start with that. And this more reactive will replace the silver. And so it forms the ion first, the copper plus 2 ion. The copper plus 2 ion combined with the nitrate ion, and you have the crossover rule to write the neutral compound. And then you have this new silver that was an ion and is now just the element alone, and that's the metallic deposit. So this is the solid silver that's formed. So you can end up with the solid silver, or you can end up with a gas, or you can, like here. So this is what we looked at here, was that zinc, and this is the more reactive. And this, in this case, is zinc is more reactive, and it will replace the less reactive hydrogen. Okay, so in the process, it forms the zinc ion, which is plus 2, and that zinc plus 2 ion combines with the chloride. You have the chemical formula ZnCl2, and then hydrogen ion is not just going to revert to H, and that's because hydrogen is never just an element on its own. It's one of those that's always diatomic. Okay, so if hydrogen has other hydrogens around, it will always bond and be present as H2. So H2 is not a solid. This is a gas in its natural state, and that's why we can see bubbles in that reaction.